Alright, I get to teach you guys all about the wonderful world of trigonometry. I don't have a cheesy joke for that one. Um, but the first thing I want to talk about is a right triangle, and at least being able to identify the sides of a right triangle. And this is going to come in handy because if we were to treat, say, the hypotenuse of this rectangle as a vector quantity, we'll be able to break it down into the x, this moves along the x-axis, and the y-axis components when it comes time. Now I'm jumping a little ahead, but that's essentially what we're going to use this for. But if I look at my right triangle here, there's an angle, theta, given. You probably recognize that symbol, Greek letter theta, typically used to show an angle. Remember that the side that's always opposite of the angle is referred to as the opposite side. And then the longest side is the hypotenuse, or that's also what you call a bathroom in an airplane, a hypotenuse. Yeah. And then the last side is the adjacent side, and I just remember that one because it's the last one. Opposite, you understand, hypotenuse is usually easy to recognize. Adjacent's the one that's kind of left over. Okay. Now, you've probably learned trig functions already, and you remember it from so, ka, toa. Okay. Now, you might remember that, but what exactly does it mean? Well, the first one is the actual trig function, so sine, cosine, and tangent, and the other two letters represent the sides of the triangle that you're utilizing. So sine here would be the sine of theta is the opposite side divided by the hypotenuse. Ka would be the cosine of the angle is the adjacent side divided by the hypotenuse. And then the tangent of theta is the opposite over the adjacent. Now what this is really useful for is if I have the angle and one of my three sides, I will be able to solve for a missing side, or for vectors, a missing component. Okay, so if I was given the hypotenuse and an angle and I wanted to solve for the adjacent side, hypotenuse and adjacent, and having the angle, I would use cosine, because cosine is adjacent and hypotenuse. So if I was going to solve for the adjacent side, I'd have the cosine of whatever the angle was, and then I would end up multiplying by the hypotenuse to get the adjacent side. Okay. Now, what happens if I had two sides of the triangle and I wanted to find the angle? Well, then we use what's called the inverse functions. Okay. So for sine, if we had the opposite and the hypotenuse and we wanted to find that angle, theta would be equal to the inverse sine, which is the little -1 above the above the sine, and then it's still opposite divided by hypotenuse. For the cosine, we use the inverse cosine, adjacent over the hypotenuse, and the tangent would be the inverse tangent of the opposite over the adjacent. Okay. Now, there's one other piece of trig that is going to come in handy for you quite often. If you had two sides and you wanted to solve for the third side, you've used the Pythagorean theorem before, which is c squared equals a squared plus b squared. This is a common way to solve for those sides, where remember that c squared is the hypotenuse. And technically, I'm sure in math class the a and b matter, but it really doesn't make that much of a difference in this case. I do want to say that in physics they use a vector version of this. So you might see v with a little arrow over it squared is equal to v with an x squared. That's the x component of the vector, and vy squared, representing the x and y components, or the x, things that move along the x-axis, and things that move along the y-axis, like the adjacent and opposite side. So there's your little trig refresher, and in the next couple of videos we'll show you how to actually solve problems using the trig. All right. Peace out.